I'm Barbara Nelson, and I'm the VP of Engineering at InfluxData. In engineering, we are busy building the tools that developers need to make their awesome time series applications. Every year, we look for new ways to do that, learning from our customers and trying to stay one step ahead to have the tools in place for whatever you want to build. That's why we have a constant focus and attention on all of our products, open source, on-prem, and our cloud solutions. We want to deliver the products that you need in whatever environment you need them in. The title for this talk is Build, Ship, Repeat. And while that could sound a bit like a treadmill, in reality it isn't. It's what guides our whole engineering approach. We identify new features or improvements to existing features, build them, deploy them, measure them, we are a time series company after all, and then start again. In our cloud environment, this methodology is particularly important as we are running across many regions and many cloud providers. We want to ship features to all of these environments as soon as they're ready. If we were manually deploying new versions of our software, we would be at risk of having a fragmented product with different software in each environment. To avoid that, and to keep the developers working efficiently, we have embraced Build, Ship, Repeat for our CD pipeline too. Every time a developer merges a code change after PR review, it kicks off an automated pipeline that runs a suite of tests, deploys to staging, runs another suite of tests, deploys to an internal production environment, runs the tests again in that environment, and then deploys to all of our production environments. So code gets to production in a matter of hours. We use feature flags to control who sees what, so we can run early access programs, test features in controlled environments, all while making sure that the same code rolls out to all environments multiple times a day. It's a very sophisticated setup, and it's awesome to see it in action. But enough about how we build. Let's talk about what we're building. I'm just going to touch on some of our more recent product additions, and over the course of the next 2 days, my colleagues will go into a lot more detail on these new capabilities. Where to start? The best place to start is with data collection. The first question you have to answer when working with a time series database is how do you get your data into the database? We have a ton of options in how to get data into the database because we know that you are working in many different environments with many different capabilities that need different mechanisms to get the data to your time series database. So we give you quite a choice. Use a client API, or our Telegraph agent, one of our scrapers, the REST API, or our most recent addition, a cloud-native data collector. Some of our partners have also built integrations to make it very easy to get data into InfluxDB. Our native collector is a new capability to collect data directly from a cloud broker and write it to InfluxDB Cloud. There's no need to run an intermediary agent, as we can subscribe directly to your publicly accessible broker and write the data to your cloud account. We're starting with MQTT brokers and would love your input on what other brokers you'd like us to support. Later on, Jean will talk about the development of the cloud-native data collector. It's been a fascinating project. Our Telegraph agent is a really important part of the time series ecosystem. It has hundreds of plugins that support a whole range of protocols to move time series metrics from many different data sources to many different destinations, including InfluxDB. While all these plugins are awesome, thank you for those community contributions, the challenge has been that the Telegraph agent has been getting bigger and bigger over the past few years. This is a problem for people running Telegraph on smaller, resource-constrained devices. So we're adding an option to build a smaller Telegraph agent that only has the plugins that you need for your use case. So those of you with small edge devices with limited memory will be able to tailor the agent to exactly the subset of plugins that you need for your use case, and end up with a much smaller Telegraph binary. On the client library side, our client libraries now come in Python, Golang, JavaScript, Java, C#, Ruby, PHP, R, Dart, Swift, and we also have 2 community-driven libraries for Arduino and C++. Shout out to the community for those client libraries. You are a really important part of our ecosystem. If we don't have a client library for the language you're working in, and none of these other integration solutions works for your use case, no problem. Just call the REST API directly, and you can write your data in that way. So now that you've got your data flowing into InfluxDB, what do we do with it? The heart and soul of our product is the time series database. There's a much more in-depth discussion on this topic later today, but suffice it to say, we've been hard at work improving the performance and the efficiency of the current database, and also building our next generation database. Phil, one of our lead engineers, is going to walk you through the architecture, showing how we store, manage, backup, and protect all the data you've entrusted to us. And we have a lot of data in our cloud environment. Across our production clusters, we are currently storing 268 terabytes of compressed time series data. Our cloud providers love us. We're supporting an ingest rate of 10.9 billion bytes per second. That equates to 11 million points per second, and a query rate of 2,000 queries per second. We've one customer who's writing about 350 gigabytes every hour. We've another customer running 80,000 queries per hour. Shout out to our task system that's supporting all of this. These numbers are just a few examples of customer workloads that we're supporting in our cloud today. Fortunately, the cloud configuration is very flexible. As we get more customers with more data, we scale up the environments we have, and we can also add new ones. This keeps the SRE team very busy, but is a smoothly running part of a well-oiled machine. So your data is flowing into the database, and it's being efficiently stored and managed. Next up is to start looking at it. So how do you query it? With one of our scripting languages, of course. We've continued to focus on both ease of use and power for our Flux scripting community. Flux is a very powerful part of our platform that goes beyond simple queries to let our users build sophisticated processes around their time series metrics. We've been focused on building a new script editor that makes it easy for you to get the shape of your data without needing to be a Power Flux user. You might wonder why we're building a new script editor as we already have a data explorer. We feel there's a great opportunity to use the script editor as an instructional aid to help folks learn Flux quickly and get comfortable with Flux as a way to explore and act on their data. This new editor includes a schema browser on the left-hand side, and as you select your measurements, it auto-generates the Flux on the right-hand side. Hit Run, and the data shows up right below your Flux query. You can also search through your results without issuing a new query. I'm certainly not doing justice to everything that is in this new UI, so make sure to watch the demo later today. We've also heard your feedback on wanting an easy way to reuse a script and not just cut and paste. We're adding an ability to save a script that you have built in the UI, and then you can refer to it later, whenever you need it. This makes it really easy if you have a set of similar tasks, for example. Just create the script once and use it whenever you want. And reuse goes beyond the UI. We've built a mechanism, invocable scripts, for you to reference your script at a public URL. If you want to run the script directly from your application, just configure your cloud token and invoke your Flux script. This turns any Flux script into a serverless Flux function. Call the URL via a REST API. We'll run the Flux script in the cloud and return the results to you. I should mention that the new script editor currently supports Flux, but it's been designed in a language-agnostic way so that we can easily add support for other query languages like InfluxQL or SQL. You can use the schema browser to select your measurements, tags, and fields. Then we'll generate the query in whatever language you select. Speaking of languages, we have continued to enhance the Flux language too. A lot of the recent work has been on making Flux more flexible, so you can write your script once and then use it with a broader set of time series metrics. For example, by adding support for polymorphic labels, you can have customizable column parameters using native Flux. This gives you more flexibility in your script as you don't need to hard-code the column parameters. Dynamic types work like a wrapper for external data, whose type is not known until runtime. We know that users want to join their data in many different ways, so the new join library now supports inner, outer, left, and right joins. It's also faster and more memory efficient than ever before. We've also added a new Flux function, isType, that lets you check your data type at runtime. For example, you can choose at runtime how to downsample a field, even if the field was introduced after you wrote your downsampling task. We're also building a way to share your Flux code using Flux modules. This is a long-awaited addition to our Flux package that enables you to easily build and share your own Flux code with your team members. We're basically building a registry where you can store Flux code and then reference it in queries, tasks, etc. The Flux interpreter will take care of loading the module from the registry. This is only a small subset of the new Flux capabilities. Make sure you listen to Nathaniel and Scott as they go into this in a lot more detail. They have some very big news about Flux. Flux isn't our only language for processing your time series data. We continue to support InfluxQL, and later today you'll be hearing more about how we're supporting native SQL in our platform. This is a very exciting addition to our platform, opening up a whole new set of use cases. In addition to new Flux language features, we've also been very focused on Flux performance. This graph shows the average performance of a set of Flux queries exercised with the same data set over the past 12 months. You can see pretty impressive gains. I love that dramatic drop in the middle of the graph. February was clearly a good month for the performance team. You might wonder how we get those gains. Most of them come from pushing down more of the query to the storage tier, where it's closer to the data, rather than reading all the data out of the storage tier into the Flux layer to process it and then discard much of it. Let me give you a specific example. If you want to group by some field, then do an aggregate window and then get the mean, as shown in this code example, a non-optimized Flux implementation would call the storage tier to get the group and then return all that data to the query tier. The query tier would then aggregate all the data and then get the mean, discarding all the raw data that had been read from the storage tier. Using pushdowns, instead of returning all the data to the query tier, a composite function, group plus aggregate window plus mean, is pushed down to the storage tier where it's executed all together much closer to the data, and then the much smaller result is returned, just the mean in this example. The biggest performance gains have certainly come from pushing down summary functions like aggregate window, but you can expect to see more gains like this as we continue discovering and optimizing our query execution for common sequences of queries. The performance team does an amazing job of measuring performance, analyzing the slow spots, and then coming up with ways to speed them up. Build, ship, repeat probably applies to the performance team more than any other team in engineering. I could spend days talking about Flux and InfluxDB, but we've got a very full agenda, so I won't take too much of your time. I do want to mention a couple of features that haven't really gotten the attention that they deserve. One is explicit schema. Databases like ours that support schema on write are very flexible in that you don't need to define the schema. Just write your data and we'll derive the schema from the data. But sometimes that flexibility can bite you. We've seen users occasionally struggle with data consistency. You collect all of this great data, and one of your colleagues writes a bunch of inconsistent data into your bucket, and now your queries are messed up. To help with this, we added an explicit schema option. Once you know what you want your data to look like, just define the schema rules, apply them to your bucket, and we'll enforce them for you. You can specify the rules for the column names, tags, fields, and data types. This is a really good way to keep your data clean and avoid type conflict errors. Another use case we sometimes see is developers who want to join their time series data with their other data, and not just SQL data. The Flux team has added an HTTP request option, so you can pull data from behind any HTTP endpoint, parse it, and join it with your Flux tables. So you can add value to your time series data by connecting it to the metadata that makes it easy to understand. Another cool use case for the HTTP request function is in this example code. By combining the HTTP request functions with the JSON parser functions, it is really easy to turn any website into a source of time series data. This code shows a simple Flux query that reads stock information, which this website returns in JSON format, parses it using our JSON parse functions, and stores it in InfluxDB. Stick this query in a task, schedule it to run regularly, and now you have a new feed of time series metrics in 10 lines of code. I should mention that the display function, which shows the response headers, is really helpful during debugging, so you can see exactly what you're getting back from the website. When you have as many options in your product suite as we do, between open source, enterprise, cloud, and Telegraph, it's great to see all the different ways that our users use our products. But while there are many different ways that our product is used, recently we noticed one scenario that was showing up fairly frequently, particularly in the IoT space. Our users were running InfluxDB open source on their edge device, using it to locally manage the edge environment. But they also wanted visibility to all their edge devices in a centralized environment, and our cloud solution is a perfect fit for that. But we were leaving it up to them to figure out how to get data from their open source instance to our cloud. It was certainly doable using Telegraph or one of our APIs, but by adding a fairly small new feature into InfluxDB open source, we made the integration seamless. This new feature, Edge Data Replication, builds upon two key properties of InfluxDB open source. First, InfluxDB open source can run very efficiently on resource-constrained systems. Second, InfluxDB open source runs Flux, which is both a functional data scripting language and a task engine that can analyze and transform time series data in any way you choose. So you can do whatever intelligent pre-processing you need to do at the edge, and then you can replicate whatever data you want to the cloud. All you have to do is create a cloud account, then specify your cloud credentials in our open source instance, along with the bucket you want to replicate. Whenever data is written to that bucket in your edge environment, it'll get automatically replicated to your cloud account. If the connection drops, no problem. When the connection comes back, the replication logic will pick up from where it left off. This makes it really easy for you to keep all the raw data at the edge, process it there, and whenever your edge device connects to our cloud, it uploads all the summary data that you want. That was a whirlwind tour of some of our newest capabilities. Over the rest of the conference, you will have a chance to learn a lot more about these and the other features we're working on. So stick around. Thank you.